Let us look at geometric progression. Let's say we are given this sequence of numbers. Let's figure out whether it is an arithmetic progression or not. 4 minus 2, 8 minus 4. You notice that it is not equal. So just this fact alone says that the progression is not arithmetic. So other type of progression that we have seen is geometric. So let's see whether it is a geometric progression. 4 divided by 2 is equal to 8 divided by 4, and so on up to 64 divided by 32. They all give the same result, that is 2. So 2 is the common ratio in this sequence. So since this condition is satisfied, we can say it is a geometric progression. Now, how do we generate this geometric sequence? Given a starting number A, we can build a geometric sequence by consecutively multiplying A with powers of R. So this is the most straightforward way of generating a geometric sequence. So the way it would be is A times R to the power of 0, A times R, A times R square, A times R cube, and so on up to whatever term. It could be an infinite sequence, in which case just dot dot dot, or we can stop at some power of R, that is A times R to the power of n. Just remember this fact that when we see this A times R to the power of n, it doesn't mean that there are n terms, because we are starting with 0. So there are n plus 1 terms in the sequence. So a sequence is called a geometric progression if each term is non-zero and there is a common ratio R where k is in the set of natural numbers. Common ratio R can be any real number. For example, let A equal to 2 and R equal to half. So how would the sequence look like, or the geometric progression look like? We start with A 2 times R to the power of 0, that is 1 by 2 to the power of 0, comma 2 times 1 by 2 to the power of 1, 2 times 1 by 2 to the power of 2, 2 times 1 by 2 to the power of 3, and so on. Now let's simplify this. We get 2, 1, 1 by 2, 1 by 4, and the sequence goes on. So here the nth term is T sub n is equal to A times R to the power of n minus 1, because we are starting from R to the power of 0. Let's continue with the original progression. 2, 4, 8, 16, 32, 64. Here A is 2, R is 2. What will be the 10th term? So T sub 10 is equal to A times R to the power of n minus 1. So 2 times 2 to the power of 10 minus 1, which is equal to 2 times 2 to the power of 9. And if we know our powers of 2, then we can just combine this into 2 to the power of 10, which we know is 1024. Now, if the nth term is equal to 16384 in the above sequence, which term is it? That is, what is n? So again, using this formula, nth term is 16384 is equal to A is 2 times R is 2 to the power of n minus 1. So here we have 2 to the power of 1 plus n minus 1. And on the left hand side, we convert it into power of 2. So we have 2 to the power of 14, which becomes 2 to the power of 14 equal to 2 to the power of n. And since the bases are equal in this equality, that means the exponents are also equal. So n is equal to 40, which means when Tn is equal to 16384 in this sequence, then n is equal to 40. That means this is the 14th term. Now, very quickly, let's look at another one. If the fourth term is equal to 16 and seventh term equal to 128, what is the common ratio? So here we know Tn is equal to a times r to the power of n minus 1. So T4 is equal to a times r to the power of 4 minus 1. And T4 we know is 16. It is given. Similarly, T7 is equal to a times r to the power of 7 minus 1, which is equal to 128. So here, take the ratio of these two. A and A get cancelled out. R cube and r to the power of 6 we have is equal to 16 by 128. Simplifying it, we get r to the power of 3 minus 6 is equal to 1 divided by 8. So r to the power of minus 3 is equal to 2 to the power of minus 3. 8, we can write it as 2 cube. And since it is in the denominator, so when we take it up, it becomes 2 to the power of minus 3. And since here the exponents are equal in this equality, the bases are also equal. So r is equal to 2. So that was geometric progression. Now, if you found this useful, don't forget to like, share, and subscribe. Questions, suggestions, and comments are always welcome. Thanks for watching. See you in the next session. That's it for now.